Hey guys, I wanted to send a video to demonstrate an example that we did not get to in class, but that you can still use the order of operations rules and the playground example, if you like the visual analogy, to help you solve it. So a quick reminder of when we're solving expressions and we're trying to find the total, we would work from groupings down to addition and subtraction. But when you have been given the total, like these examples, and you're trying to find a piece of the equation, you're going to reverse the operations, and therefore you also have to reverse the order of operations when you're trying to find a piece of the equation. Okay, so with that in mind, let's look at this example here. This is one that you did see us do. For example, if we were pretending that a student was on top of somebody's shoulders when they were standing on a chair, and then we had somebody off to the side, who would we take first? We would take the one by itself first, and this is following this order, reverse order of operations. We're going to do subtraction before we would do division when we're working backwards. So we're going to add the 3. What we do to one side, we must do to the other. That will cancel these 3's out, leaving us with still z divided by 4. These are gone, equals, and we can simplify that. 1 plus 3 is 4. All right, so now to disconnect the 4 from the z, we got to do the reverse of division, which is multiplication. What we do to one side, we do to the other. That will cancel out the 4's, leaving us with just z equals, and then we simplify this. 4 times 4 is 16. And then if you performed the check, does 16 divided by 4 minus 3 equal 1? 16 divided by 4 would be 4, and 4 minus 3 is 1. So yes, we did it correctly. All right, so take that same concept knowledge and apply it to this one. So when you're doing these, remember that a numerator expression, so an expression that's in the top of a fraction, is considered a grouping. So if it helps you, you can put the parentheses there. And that reminds you that you're going to be way up here. So when you're working backwards, you're going to save that grouping for last. All right, so we have a grouping that has subtraction, but technically it's a grouping. So that is what you're going to tackle last. And then you have division. So division definitely comes before grouping, so we're going to take care of that division first. Now, with the analogy of our playground example, this is how I usually say it. So if you're on the playground and you're playing, let's say like in the tower up there, and even on our playground, if you had t and negative 85 hanging out in the tower, oh, you can't see that, hanging out in the tower above, and you just had 3 down here on the ground, okay? So if you just had 3 on the ground and this grouping hiding in the tower up top, who would the administration come and get first? They're going to get the one by himself on the ground before trying to climb up in the tower to separate these two, okay? But again, remember, true rules of math, it's because groupings are the very last thing you'll take care of when doing reverse. So in this case, we've got to get rid of our division of a 3 first. And how we do that is by multiplying. What we do to one side, we do to the other. Those cancel out. And then we can simplify this. So 3 times 4 is 12. And now this fraction is gone. So we just have t minus 85 left over. And now we can take care of the grouping because there's no other operations to handle before we get to the grouping. So to move the negative 85 away from the t, we're going to add 85. What we do to one side, we do to the other. That will get rid of that, leaving us with t. And then we would solve this, 97. So t is 97. So I hope that helps, but just remember, when solving for a piece of an equation, you will work order of operations backwards.